Okay, so 5.2 video, exponential functions. This will be day 3. In day 3 video, what you're going to see is we're going to learn about the number e. No, I'm not saying that wrong. It's actually the number e. You know that pi is a famous number. Well, e is another famous number that I want to talk to you about today. And then what we'll do is we'll learn how to solve exponential equations. So hopefully you have your thinking caps on today because this video might be a little bit longer. This is going to be a tough one. So let's get started. All right. First things first. Learning about the base e. Learning about the number e. What I decided to do was kind of give you this XY chart. And I'm going to ask that you kind of do this in your graphing calculator. I'll do the first one with you to kind of get an idea. So I'll do to the 10, like when x is 10. I'm going to have you try the rest of them on your own to see if you can get the XY chart that I do. So what I'm telling you is that what we've learned about exponential functions, I think what you've noticed in the activity that we did with exponential functions, as x got smaller or as x got larger, we saw that it got closer and closer and closer to this line that's y equals 0, which is called your horizontal asymptote. It'll get as close as it possibly can get to it, but it'll never actually cross it. Believe it or not, I'm going to show you this discovery activity. I'm going to tell you, here is how we figure out the number e. I'm going to take 10 and I'm going to plug it in wherever I see an x. So in my calculator, I'm going to do 1 plus 1 divided by 10, and then I'm going to raise it to the 10th power. Okay, so in my calculator, I'm going to do 1 divided by 10 first and hit equals. I'll add 1 next and hit equals. I'll then raise it to the 10th power and hit equals, and what you should see is that you should get a number that looks like this. Notice that I did 5 numbers after the decimal point. I think what I want you to do is 5 numbers so you can kind of see as x approaches infinity. So notice as x is getting a lot larger, you're going to notice that these y values are going to start to approach a certain number, and voila, that number is going to be e. So understanding that when I do this, I'm going to get that number e. Okay, so notice that I just did 100 for you. If you plug in 100, you'll get that 2.70481. Okay, so from here, I'd say try to pause the video, see if you can fill out that XY chart. Alright, so the rest of the XY chart, after you have paused the video, you should have got that, and that. Oh my goodness, notice that the last 2 of them were the same. Guess what? As x is approaching positive infinity, e is approaching this number here. So what do you think e actually equals? Well, it's that number right there. So e is approximately 2.71828. Going to be important that you kind of know that number. So now add that to your toolbox. You know pi is 3.14159, etc., etc. So now you know e is 2.71828, etc., etc., etc. Okay. Next, what I want you to do is graph e to the x in your graphing calculator. So go into your y equals screen, graph e to the x. Sorry about that. That was a dog squeaking her toy. Anyway, so go into your graphing calculator, hit y equals. Notice down on the left-hand side of your graphing calculator, you will see a button that says ln. Above that button, you will see in yellow y equals e to the x. So second ln e raise it to the power of x and graph that. Make sure you're looking at a standard window. Hit zoom 6. What you should notice is that you get a picture that looks something like this. Just a heads up. I knew before I even graphed this that this thing was going to be an exponential growth because I knew that the b value was greater than 1, right? I know e is 2.71828, so because it's greater than 1, I knew before I even graphed it that this thing had to be a growth. Okay, so there's a sketch. What characteristics do you see that are similar to the exponential functions that we were working with earlier? So think about the activity and your exponential functions. What do you notice are the same characteristics that you have with exponential and e to the x? Okay, some things I notice. Well, first of all, e to the x is also 1 to 1. It passes the vertical and the horizontal line test. I also notice that the domain is the same, negative infinity to infinity. I also notice that the range is the same. It's 0 to infinity. That must mean that I know there's a y-intercept at 0, 1. I know there's an asymptote at y equals 0. Okay, so all of those characteristics are absolutely the same when we talk about graphing exponential functions, and when we talk about graphing e to the x, same deal. Okay, so understand, voila, there is your e to the x function, and now we're ready to get into the fun stuff. Okay, so this is the stuff that I think is going to cause you a little bit of stress, so here we go. Let's make sure we're really paying attention to this. The advice that I will give you. Alright, sorry about that. Hopefully that's the last time I have to pause the video. Not sure where I was, where I left off, so I think I was saying something like, okay, let me give you some advice on how to solve these problems. And the advice that I'll always give you, the very first thing that I always try to do, I always try to make the base the same. I know that this 2 is the base, right? 3 is the base, 100, 1,000, those are the bases. So what I'm going to try to do is somehow make this side's base and this side's base the same. How I'm going to do that? Well, I'm going to ask myself, can I make 32 into a base of 2 somehow? I can. So I think I could rewrite 32 as 2 to the 5th power. And notice I kept the left-hand side the same. So once I have the bases the same, what I can do is drop the base and set the exponents equal to each other. And in this case, well, I knew already before solving this algebraically, I knew 2 to the 5th power was 32, but now I just showed you how we could do it algebraically because I don't think you're going to be able to do these in your head. So understand, make the bases the same, then drop the base, set the exponents equal to each other, and if you need to, solve for x. Alright, let's get a little bit more difficult. Letter B. So I'm thinking I got a base of 3 and I got an 81. So what I'm going to try to do is make this 81. Somehow I'm going to try to make it into a base of 3. So I'm thinking 3 to what power? Is 3 to a certain number? Is there 3 to something that's 81? Well, I know that 3 to the 4th power is 81, so voila, look at what I just did. I made the bases the same, so now I have the same base. I'm going to drop the base and set the exponents equal to each other. and then I'm going to solve for x. And voila, x equals 5/2. Hopefully, not bad so far. But sometimes you're going to have to change both bases. There's a massive hint in this problem. So before, I only had to change one side to make them the same, but I'm thinking 100 to a certain power isn't going to give me 1,000, and I can't obviously take 1,000, like 100 to some number isn't 1,000, 1,000, it's just not going to work. So I'm going to have to change both of them somehow. So I'm thinking 100 and 1,000. What base could I possibly make them so they're the same? Oh, I think I got it. I think I can make them into a base of 10. So notice what I did. I rewrote 100 as 10 squared. I left the exponent alone, didn't touch it yet. I rewrote 1,000 as 10 cubed, didn't touch the exponent yet. Think about my rules of exponents. I know when I have exponents right next to each other, I keep the base and multiply my exponents, so let's clean that up a little bit. I distributed the 2 here to get 2x plus 4. I multiplied 3 times x to get the 3x, so it looks like now I have the bases the same. I'm going to drop the base and set the exponents like equal to each other. And I'm going to solve for x, and voila! I have just taught you how to solve exponential equations. Hopefully you're going to take my advice. Try to make the bases the same first. Once you have the bases the same, you can drop your bases, set your exponents equal to each other, and solve from there. So, hopefully you had your thinking caps on, and I want to say, fantastic job.